Hello, everyone, and welcome to today's webinar titled The Benefit of Using an Independent Quality Control. I'm Susie Valdez of LabRoots, and I will be your moderator for today's event. This educational web seminar is sponsored by Biorad Laboratories. I want to invite everyone to participate by submitting your questions during the presentation. To do so, simply type them into the Ask a Question box located on the far left of your screen and click Send. Any questions we do not have time for during the webinar will be captured and responded through the Q&A list that will be posted next week in the event resource box, which is located below the Ask a Question box. You will also be able to download this presentation handouts from this event resource box starting on October 30th. And if you have any trouble technically or seeing or hearing this presentation, please contact us through the Ask Us Question box and we will address those issues. As a reminder, this presentation is educational and offers free PACE continuing education credits. Click on the Continuing Education Credits tab in the top right corner of the presentation window and follow the instructions to obtain those credits. So let's get started. I now present today's speaker, Mr. Abobaker Yagoot. Mr. Abobaker Yagoot is the Biochemistry Supervisor at the National Guard Health Affairs, which is the large healthcare system in Saudi Arabia, with over 3,500 hospital beds and 3 million outpatient visits every year. Mr. Yagoot trained as a medical technologist in Ontario, Canada, and continued his work there for 10 years before moving to Saudi Arabia and taking a position with the Quality Assurance and Quality Improvement Office of King Faisal Specialist Hospital and Research Center. In addition to these roles, Mr. Abobaker Yagoot is Certified Inspector for the College of American Pathology, or CAP. These combined experiences make Mr. Yagoot well qualified to talk to us today about the value of independent quality control. For a complete biography of him, please visit the Biography tab at the top of your screen. Abobaker, welcome. You may now begin your presentation, sir.
Thank you, Susie. Thank you for this kind introduction. Actually, the pleasure is mine to be able to participate in this kind of seminar related to all kinds of quality-related issues. And thank you for giving me the opportunity to share with you our laboratory's findings and troubleshooting. And like I said, this is going to be for the next 40 minutes, you're going to spend some time in our laboratories, and it's not just going to be a presentation, it's actually going to be an invitation for all the audience to come and share with us our investigation. With that said, I would like to start the presentation. The heading is, as you can see, is just the benefit of using an independent quality control, and those are case studies. And that's what it is. We are going to see a lot of prints, screenshots, quality reports. As this, consider this, you're going to spend another 40 minutes in our laboratory, so we're going to show you everything. It's not going to be like where you can say if one control was out, what you do. But in this case, we're going to show you this lot number, this reagent, this day it was out or it was in, and what happened. So it's like just coming to our lab and seeing all our records. There's no financial conflict to disclose here. We work with all the companies, and we're just going to show you our printouts. Okay, learning objectives is going to be, by the end of this presentation, most people will identify at least 2 benefits independent QC can provide when troubleshooting an out-of-control event. They will also be able to recognize at least 2 advantages an interlaboratory comparison program can provide. Most of our work is going to be about it. Third-party control, independent control, how it helped us, and how we were helped by comparing our result to our peers. That is the main thing of all the case studies that we're going to show you. Today we're going to talk about 4 examples. We have a lot of them, but for the time, and we can explain it in details, we're going to talk about 4. One of them is gamma GT, GGT. We're going to talk about vancomycin. We're going to talk about microalbumin, and another case study is about free P3. I was told that my pointer doesn't work, so just to make it easy, I have a lot of red rectangles and a lot of red circles to show you like exactly where to look, because we cannot just narrow down. This is a case study. I have to show you the whole report, but then I'm going to show you where you can see which one I'm talking about. So just to make sure here that you follow me when I tell you my control was out or my control was in, I just want to share with you and our report at the end of the month. We get a QCNet monthly report. There's a lot of them. There's many different independent, but it just happened that we use Biorad. So this is what my report is going to look like. Very simple. Anybody, you can, not even with experience with quality, all you're going to see here is you have the white area, light green area, and the dark green area. And the vertical line is just showing your standard deviation index, and what it's going to show you is your bias. That's why it's from 2 up to -2. So you're either on the positive side or on negative bias. The CVR, coefficient variation ratio, is going to show how precise you are. And your laboratory is going to be represented with a dot. So if the dot is in the white area, it's good, and the dot is outside the whole rectangle, it is not good. So with that explained, this is just formulas. You can look it up, so we're not going to discuss formulas. We can start the first slide with our presentation. This is the gamma GT, and again, this is a printout from QCNet, and all you have to look at that red rectangle in the bottom with the 2 red circles. The one is for level 1, on the left red circle, and on the right red circle is for level 2. And you can see the dot. We say the white area is good, the light green, and then the dark green. So the dot is, well, you can see it on the red circles, it's way on top, and at the end, it's almost out. Anything outside there is going to be you're out of your peer comparison. You can see also here, this is the laboratory comparison compared to your other peers, to your other peer group. Again, you just have to look at the red rectangle area, because the next one underneath is glucose, IgA. You can see the dots right in the middle. But when it comes to the red rectangle area for the gamma GT, you can see that on the left side, the 2 green circles, level 1 and level 2 for the chemistry assay, and then you can see them on the blue circles in the middle where they are on the outside. Again, you have the 3 rectangles red on the right-hand side. That's just to show you with the report. It gives you your laboratory for this month, how you've been performing, what was your SD, what was your CV, and it also gives you cumulative, since you start that lot number, how you've been performing. Next to it, it will show you how your peer group is performing, and next to it is showing you how the method group is performing. So you're being compared to all these people, and you're sending, we run our control 3 times a day. Imagine 3 times a day you're sending your controls and being compared to all your peers. Okay, so with that case, this is one report. Of course, the monthly report is a very long report, and I just got 1 slide from each. The monthly bias, you can see here, the red rectangle again at the bottom, that's for the gamma GT. It's run straight line. It's continuously on a positive bias. The next slide will make it a little bit easier. See the red rectangle again at the bottom for the gamma GT, continuously going on the positive bias. Each dot is 1 month. Every month, every report, it was showing that we're going on a positive bias. Just one note though here, it hasn't crossed the line above. It's not outside where it's not acceptable. It's just on the borderline. And you can see this continue. This thing, by the way, went for about over 2 years. Every month we've been investigating, we've been calling other hospitals, what's going on. If I have to talk to you about all the investigation that we did throughout the 2 years, it will take another presentation. So we were investigating, but then you will see what the reason was. Now, there are 2 questions here. What happened And one question and one presentation it came, which I'll tell you what happened, but one presentation, and one of presentation, a question came up that why we did not establish our own range. But this is going for about 2 years. You went through so many different reagent lot numbers, different lot numbers of controls. Your machine had preventive maintenance maybe twice or 3 times on that period. So why don't and that's how your machine is running. So why don't you just go and establish your range, and you don't have to look at your own positive bias. And that was one of the questions. But the answer is, like, what this means, what you can see here, this is a report from your peer group that about 100 labs around the world, they're telling you, no, we're using the same lot number reagents, same instruments, same lot number quality control, and we're all the same. You're the only one on a different side. So what's the point of establishing your own range? It's just you're hiding the problem. And that's why it took us a little bit longer. That's our problems. But at least we did not give up. We did not think this was okay. We knew every month we thought it was something going on and we need to find out. If we had gone outside the limit and the report says warning, then we were going to stop the assay and look for something else. Now we're going to show you about what happened. I mean, you're probably wondering all this for 2 years. What happened is there was a product information that recommends that you adjust the gamma GT calibration factor using a standardized alignment solution. Now you're talking about the the calibration factor, which you need to multiply every result with it. And if you have different number, then all your results will be different. We received this product information, as you can see here. We received it on the 20th of November 2017. And if you look on the left side, that red rectangle next to it, it says the date issued was September 9, 2014. It was like about 3 years. For some time, of course, you haven't received the reagent yet, and then you start receiving the reagent, and it's about 2.5 years that took us. Now, here is the problem. Here is you have, let's say someone came from a vacation, they were deleting their emails, they did not send you the product information, whatever. The question is, do you have a checkpoint in your laboratory where you can find out if there is any problem like this? It could be this one, it could be anything, there's many problems. At least in this case, a third-party control or independent control, and comparing to your peer, at least if you don't receive this thing or if you have any problem, there are a lot of labs around the world that you've been compared with them throughout every month. They don't have the same problem. So they're going to show you that, no, you will find out that they're working different than yours. And that's where you find out how you're doing and you start investigating. So although we did not have this product information, but we had a checkpoint, which was the third-party control and the peer comparison. Now, to know the disadvantage of not having a means of comparing your QC results with your peer group, example like Unity or any other company's softwares if you have, look at our instrument printout before changing the factor. It looks okay. And then, because if you're comparing yourself to yourself, then you're not going to find out if there's a problem. I'll show you the next slide, and it's going to show you that after we change the factor, it looks okay. So if you don't have any comparison, this is where you will look. Now I'm going to put the two graphs together for you, where the first one ended and the second one started when we changed the factor. And that is, this is what you will see. See the red circle here where the vertical blue line is where we changed the factor. And you can see that factor was changed on December 26, 2017. And we found out, you can see the two red rectangles inside the red circle. That one was the results before the blue line was 67. And immediately after changing the factor and run the same control that was sitting on the bench, and it gave 57. That's about 18% difference. So we were running at the 18% false elevated results. And that reading, that was showing you, which explains the years of continuous positive bias for QC as well as for patient results. We did not give up. We did not establish the range. And this is what we're saying, just some investigation might take you a day or 2 days or even longer. I mean, this took years, but at least now you know you can fix it. Now, this problem is solved and everybody's happy, everybody in the lab was happy and everybody can go home. But is there any further action you want to do? Now, in this case is, like I said, before that blue line, you were running on a 18% positive. If you did not have a third-party control, or if you didn't know that you were compared to your peers and you know you were even going higher, you might have been harming patient. So whenever you solve your problem, it's a good practice to go back a little bit and see what happened to the patients. In our case, no patient harm was done. Like I said, on the bottom rectangle here where you can see, we were just on the borderline, but we did not cross the acceptable limit. So that means there were people around that area, give or take every month. So we were okay. But for a laboratory, and you see the top left rectangle here, where we participate also in Westgard Sigma verification program with CAP and everything. And for a lab that is performing at 5 sigma, 6 sigma, to see one analyte going like this, we knew there was a problem and it wasn't acceptable by our standards. And that's why we continuously investigated. Now, if we did not have the third party, if we didn't have people telling us, our peer group telling us that, no, you're running on a positive bias. Maybe that was, in our case, we were like, it was 18, it could be 20, 25, to the point where you can harm patient. What would be the magnitude of the risk if there was no peer comparison? The direct effect of all that to the patient would be, like, we can see how on that period, you can see where it says number 1 on the left, green circle here, on that rectangle, you will see on that period where we had the gamma GT problem, we ran about 329,342 samples of gamma GT. That's the number of samples on that period. You can calculate and you can find out the number of patients, from how many patients that one came. We're actually lucky we have the Allen IQ, the BIS software, which calculates turnaround time and a lot of things, how the instruments perform. Among those things, it also calculates for you on that period number of patients at samples, number of samples per patient, number of patients per day, and it's all the statistics. So this is where this 3.3 samples per patient came from. So on that period, we were having this 329,000 came from about 99,800, which I just rounded to 100,000 patients. Now you can see, we were talking about all this gamma GT was going higher. If there was a problem and you were harming patient, you would have been harming about 100,000 patients. If your problem was 1 day, you could harm your population of 1 day. If it's longer, you're going to harm a little bit more patient. To show you now, just to see what happened, you have to, if you harm those patients, you have to call them and you know all whatever you're going to do. But let's see here as a lab, what do we do to avoid a problem like this? Or how can we protect, or what can we learn? Let's see the cost of good quality versus the cost of poor quality, which means what do you invest ahead of time or what you pay at the problem solving later, or a damage control. In our case, and this is the real data here, we use 1 vial per 3 days. That quality control, it takes 3 days to finish it. So it takes about 10 vials per month for 30 days. A kit comes with 12 vials. That's about 1,000 Saudi Riyal. This is an old price. It could be like 1,500. I don't know, but let's say 1,000. And we use level 1 and level 2. So we're going to use 2 kits per month, which is going to make it 2,000. That period that we had a problem with gamma GT, also let's say 3 years, that's 36 months. So we actually invested 72,000 Saudi Riyals, which is about 19,200 US dollars. This is the real data. If you, again, this is like coming from the real lab, where if you have 3 instruments and you run 3 times control per day, you will end up using about 1 kit per month. So that's 19,000. But on the other hand, if you had harmed those 100,000 patients and they sue you and the court, let's say, for example, that they award about 1,000 Saudi Riyals per patient, which doesn't happen, that's about $300. You don't get harmed by a lab and go sue, and then you get $300. But just for example, if we say you're going to give 1,000 Saudi Riyals for those 100,000 people or patients, That's 100 million, which comes to 26 million US dollars. Now, just trying to show you the difference. If you invest up front, and people don't look at it, this is just for one analyte. And 19,000, we use that control to monitor about 32 analytes that we have, 30 or 32. And if you harm a patient from one analyte, you can go up to this much. Just to show you when you invest ahead of time into checkpoints, quality, to confidence of your instrumentation. It's a lot cheaper than when you have to do damage control. And this is what I mean by the cost of good quality, cost of poor quality. But if you really want to know about cost of quality, then you can actually, as a good topic, you can go to CLSI reports, understanding the cost of quality in laboratory. And that, because the cost of quality is a lot of details, and you're going to talk about cost of quality for return of investment, cost of quality, prevention costs, appraisal costs, upfront costs, cost of poor quality, internal failure, hard costs, soft costs, all these details, and there's a lot of templates, forms, charts to use when you study about cost of quality. And so you can read it there. Always when you have a report like this, just look for the updated one if you're going to read it. I'm not sure what is the latest one. But again, on one note here, the next webinar actually after this one is going to be about cost of quality. So this is an opportunity. If you look and this one attracts you to know how much is going to still attend, you can attend the next seminar and you'll learn a little bit about cost of quality. After the problem, so this is quickly, I'm going to go, this is before changing the factor on the left side, and you can see the red rectangle on the bottom where the red arrow is showing you that we were on high end. And then after changing the factor, we have to wait and then print the report for you so we can attach it here. And the blue arrow, you see we're back to the red area, which that's the improvement. And here, this is laboratory comparison compared to our peers. On the left side, you can see the red arrow, we were out, and then here we are almost on the average among the best of the peers, right in the middle. Again, before and after with the imprecision report, you can see the red arrows on the left side, we were running continuously, and then the blue arrows, everything, we're not a positive bias anymore. Now, when you hear something like this, you think, oh, how often this happens? It doesn't happen to me, or it doesn't happen to anybody. And it just a lot of times we troubleshoot, we investigate, and we don't keep record. We just let it go, and then it happens a year later, and so we go through the same problem. Now, learning from our mistakes, and what are the chances of this will happen to your lab? Or what are the chances that would happen to us again? Well, let me share with you this one. We had our second wave of gamma GT, a positive bias, after 2 years and 9 months. On 29 September, that's like about a week or 2 weeks ago, we were trying to do a dilution. We had to look. So look at the number one. This is 29 September at 6:39 a.m. The QC was like this, and then 59. And then you see the red vertical line, something happened, everything shifted up. And then you see the blue vertical line, the green vertical line, something happened and everything went back. So what happened? The next one, when you see that this is the result after something happened, after the red line, and it went up. So the question is, what happened? Immediately right there, because we had the same issue, everybody in the lab said, wait a minute, maybe this looks like the factor problem that we had years ago. Because people had documented, and they remember, they learned from it. We didn't go looking for reagent to calibrate again. So what happened was, in the morning, we had downloaded an assay file. And when you download a new one, always the default goes to non-IFCC factor. And that one changed. But so it took 1 day, and this is the second day at 6 a.m., 6:44 a.m. control. And then after that, we had called the company the day before, and they came the next day, and they changed the factor to IFCC factor, which is the one for our instrument. And immediately we ran the control, and you can see it went back. Now, if you see from number 2, the first result after the red vertical line was at 1:25 p.m., 29. And then if you see the first green result after the green line is on the next day at 6:44 a.m. At 3:22 p.m. That's a difference of 26 hours. And it's the same issue that took us before about 3 years. At this time, the problem was solved in 2 days and not 3 years. That is just to show, keep record, share information with peer like this so people don't have to repeat the same mistakes and so on. It's just learning from things. Why IFCC factor? Some people might say, what is IFCC factor? It's just the factor for the instrument gamma GT insert package. Will tell you it's highlighted if you can see it. CAP, the CB 2020 kit instruction tells you you're an IFCC, product information, and the two screenshots on the bottom, as on the left is the one when we calibrated, and you can see that's the non-IFCC calibrator that came down, and we were getting the wrong result. The result shifted up. And then when we change it, you can see the different value of the IFCC factor. And that's how we solve the problem. Now, this case has got a lot of things to learn from it, but to summarize it is the monthly report showed a marginal performance continuously on a positive bias for a long time. But investigation showed that the vendor product information letter recommends adjust calibration factor. Calibration was adjusted, problem solved. Unfortunately, we had a second wave of gamma GT, but because of the record and learning from previous experience, we solved it immediately within the same day. And this case, it just showed you that because we're being compared to our peer, that's how we found. But if you are going to go like this for years, you're just going to go establish your range and continue, and you don't know if you're having patient or not. Okay, now we're going to talk about, this is the second case that I have. Normally people, they tell you your control was out, and whether it's your peer group or something, they tell you you're out and you investigate. This is a different scenarios from the other side, and I think a lot of people in the lab are going to like it. And this case, what we had on February 2018, pharmacy called, and they said, you're giving us the higher results than expected for a trough vancomycin level. So we checked our results on instruments. We checked our QC results and QC history on Unity, how it's been performing, if something happened before and we didn't notice it. We checked CAP sample surveys, everything was okay. And our controls are good compared to peers. So we called the pharmacy and we told them, look, this is the problem. We don't have anything. It looks everything is okay. See if there's anything on your side. Maybe there's a mix-up, samples, whatever. But the problem has gone for about 3 months at that time. Now, I'm going to show you, this is in our lab. This is our Unity, 2 instrument performance with quality control material. And this is compared to peer group 75 labs and method of 122 labs. Our result compared to them was right in the middle. You can see the red rectangle and the 2 of them. Those are 2 instruments. And if you can see inside the red rectangle, level 1, level 2, level 3, the dot is where we stand compared to our peer group, and right in the white area in the middle. So with quality control, we're performing very good. That means if those samples that the pharmacy are complaining about, they had gone to any of those 75 labs around the world, they would have got the same result. So hopefully we are performing, we don't have a problem. It's just to show you that you don't go crazy and recalibrate and try to find out a less result to compare to it, but it's just giving you confidence. Now the question is, if the instrument is performing like this with quality control, is there any chance that it will perform differently with patient? That with patient all of a sudden it would give us a high result and with the control is good? Now let's see. This is the result of 2 instruments with a patient sample in the past 2 years. I'm just going to explain what the graph is. This is a total number of vancomycin critical results. They found to the physician. Like every lab, you have like your troponin or your potassium when result is critical. It flags it red your system, and you wait, you call, and then you read back with the physician, and then you put the comment in the system, and then you release it on the system. So this is among our list, and every lab have their own list. Vancomycin happened to be in one of our lists. So we had this data to go back and look. So we went back from January 17 all the way to September 18. Of course, it didn't start like this. I just did 3 months to see what the pharmacy is talking about. And then when we looked at the picture looks like this, I was carried away and I continued backward to January 2017. Which means is, you see those numbers is how many critical results we call per month. And the red line before the green vertical line is before what something happened and then after. So you can see we're on average about 65, 70 vancomycin critical results, high critical results per month. So we were about, all of a sudden around that green vertical line, something happened. We start reporting an average of 85, 90 per month, and it stayed the same. So definitely there is a problem with the patient. We look with the quality control, the instruments were working perfect. You look with this here, you can see this picture, something happened right November 2017. And you can see that the blue arrow is on February 18. That's when we received the call. And then we didn't go crazy looking to try to solve the problem. We called the pharmacy and we gave them just about 2 months before this green line and 2 months after to show them there's a difference. They discussed in their meeting. And we found out when they called that I'm going to show you now what happened. I'm going to show you what happened, but why this example? Always when you have a third-party control, you're being compared to other people, everybody's working the same, and you look, okay, don't go, when you receive a complaint, it could be a nurse that mixed sample, there's something, a pre and post they were mixing, don't go crazy and investigate that, unless you have a real reason. Investigate, but just make sure that you know you're also okay. But what happened is, I'm going to show you the problem was pre-analytical, but here where it says up to 75% of lab error occurs in pre-analytical phase. We hear that a lot. I don't have where the source it came from, but what is pre-analytical? Most of the times in the lab, when we hear pre-analytical, we think, oh, the centrifuge, it wasn't centrifuge good, or maybe the porter took time to bring the sample from the collection area. That's how the patient did not fast, that's pre-analytical, or, go all the way to the patient, you go pre-analytical. But nobody would go any further. Let's show you this example was, pharmacy investigated, they looked, and then they found there was a memo on January 18, and they called us on February, that says there was an urgent recall for replace the vancomycin. And concerns were raised from clinical pharmacists regarding an alarming increase in the vancomycin trough results. There was a problem with the medication. So that graph that I showed you were before that green line is when we start using the medication on the patient. And everything before that was a different number of medication, everything after. So just to show you the data that laboratories has, this kind of data, this kind of graph would not be presented by the pharmacy, and it cannot be presented by the manufacturing company that manufactured the medication. It's the lab that shows you things like this. A lot of data in the lab. Now that with a lot of softwares that we have, we can even present a lot more. We can benefit from all the data that we have. So to summarize that one, pharmacy called and they say they're having higher than expected result for vancomycin. Unity report showed performance, good performance, which gave us the confidence to not to go crazy and to discuss with the pharmacy. No further investigation, analytical phase. An original problem was found to be pre-analytical, which was the medication. I don't know, I put pre just to show you how far you can go with the pre-analytical. It's not just the centrifuge, not just the report, or not just the patient. It can go pre all the way to anything can happen with the lab result if you have an independent control with compared to other peers, then you know whether you're doing good or bad, if you're okay or not. We're going to go to a third case, that's microalbumin, urine albumin. This is almost as okay like in every labs. And 19 February 2019, Unity real time, our monthly evaluation report shows urine chemistry lot number that expires on this. Again, like I said, this is case studies. We're not just giving an example. If you had this lot number that expires on this time on February 19, 2009, you can go back and see how your results was. So this is a real case. And what happened, 2 levels of control outside the acceptable peer group. Compared to 69 laboratories globally, and after combining 2,434 points. And after all these two, for you, if you are out, that means there is a problem with you. All these people are telling you, no, you're not performing like us. And that was for 2 instruments. We have 2 instruments. So definitely there is a problem. Immediately, and now if you can see, we looked at a Unity report. This is what we got. This is what alarmed us working. And then you see that the first red circle on the left, that's what it's telling you. You can see the dot is way up, and there's a little arrow above it. That's out. That's not like the gamma GT where it used to be just at the border. This one is way out. So now you have a problem. And the report, monthly evaluation report, is telling you on the right-hand side, the red circle is telling you warning. Now, all these labs are telling you, you know what, you are performing way out, you're harming patient. You immediately have to stop in this case and solve the problem, that you cannot continue. And this one, it can be like anything in the lab. I said there was, if you can see the scan at the bottom where it says calibration, the microalbumin assay must be calibrated using a microalbumin calibrator with the -03 supplied separately. What we had was the one in our fridge, we had the one that's at the end 02, and now it wants to be calibrated with 03, that ends with 03 calibrator. Supplied separately. Now there's 2 cases. Either we had the previous calibrators and we did not get rid of them when the new calibrators came, or the suppliers, they had the lot number from before, nobody noticed, and they send it to us and we put it on in our fridge. Things like this, you don't catch it because calibrator is good and everything is okay, unless you have, let's say, in some of them, they come with that pink notice where it tells you, wait a minute, this cannot be calibrated. Maybe it was there, maybe it was thrown, but we don't know. But at least the ones we had, it didn't have this notice. So there's no way you can find out. But thank God that when you have a peer group comparison, you can find out if there was a problem. So you can see that the gamma GT was a different problem. This one is different, and they're all being caught by an independent control and a peer comparison. Now, the main thing with this example is to show you, this is a printout from our instrument. You see that the line where it says calibrated here, after the calibration, it went down. And that was the problem solved. But the main thing here is not like changing calibrator and solve the problem. The main thing is look at the red rectangle on the bottom, and it tells you on February 19 at 3:40 p.m. On February 19 at 3:40 p.m. we solved the problem and we went home. Now, if you participate in CAP or Unity, after the result is online, a day or 2 days later, they send you an email saying your results is online. And a lot of people, they're busy. And once you see this emails, then you start looking at it, download it, and see. In our case, this is an email. You can see the red arrow. That's to my name. It came at 9:04 p.m. on the same day. And that to show you why we're using this example. On the bottom now you can say email from Biorad on February 19 at 9 p.m., which was going to be open on the next day. But investigation done and problem solved for 2 instruments at 3:40 p.m. So 3:40 we finished, we went home, problem solved, and then at night we were notified. But that means, how did the lab do that? Unity report, it comes on the 16th of every month. We don't wait until the 17th or on the 18th that Unity tell us your results online. Same thing with CAP. As the minute our result is online, our QI will send us an email saying it's online. So that way, which shows you this takes a lot of dedicated people working. I just showed this example to show you there's a lot of people who have a monthly checklist. They wait for things. They don't procrastinate things. The minute they have the thing, they start working on it. And third-party control by itself is not going to do anything. Peer comparison is not going to do unless you have the real people who are waiting in the lab and understand and proactively try to solve the problems. That way, in this one, he saved about 2 days, like 24 hours. It's better if I had come in the hospital at night, I would be very happy that the problem was solved when my samples were sent to the lab, as opposed to the lab were sleeping and they fixed the problem the next day. So this is an easy example. It's a factor problem. It's a calibrator problem. But just to show you how it was caught ahead of time and solve it immediately. I'm not sure, see, a lot of times people say invest on good people, and we do have a lot of good people here. Now, Unity report for January, this is a summary for that. Was the two controls for the two instruments outside the peer group? We said investigation as per reagent insert package. We found out need different version of calibrator than the one in use. Calibrated, problem solved. The minute we printed this one, actually there are three people. I went to look for the history of the problems, QCNet. Our QI went to look at Unity daily, what happened. Our senior from the bench, he wanted the fridge to look at the calibrators and the insert package, and everybody started working. It looks easy now on slides, but it's a lot of work went into it to solve this problem also. Now we're going to show you the last case. This is about free T3 for people who are aware about the 6-point calibrator. Product information was received on September that we are going to receive a new reagent, a new assay file that needs a new assay file, of course, a new calibrator. And this time the calibrator is going to be a 6-point calibrator. Before that, all the time, a free T3 was being calibrated by 2-point calibrator. So we waited and we finished our reagent, what we have. And once we came to the new reagent, you stop the machine, you download the new assay, you load the new reagent, all the steps that you know. And then you run your control. Immediately after starting the new calibrator, Bio-Rad QC results were low outside the manufacturer range for two different lot numbers. At that time, we were going to switch from one lot number to another. So we were validating the next control, and we tried the two of them, they were out. The two lots of independent control picked up the problem. Sure, there was a problem. We asked the company to give us a single company control, all levels on the low side, but within the range. They were on the low side, but within the range. If I am in the lab and I'm using them, I would have accepted the patient results. And it wasn't out to the point where you can say very low. No, it was in, but on the low side. You notice on the low side because you know the two independent controls lot numbers are going very low, so that's what alarmed. Otherwise, it was within acceptable range. We would have run a patient. The manufacturer control, so did not pick up the problem. We can say that, but we ran the previous CAP survey. We had the one we had was CB 2019. We ran it again. One sample was out, and the rest PT samples were on a negative bias. Some people might argue here that some analytes are not stable and some of them. So this is not a good judgment. But when you have two independent control are way out and one control is in, we thought there was a problem, and we asked for investigation, and we called our partner to give us a different lot number of calibrator. This is what it shows you. This is, we were going like this, continuously was going until you see that arrow, well, the red circle, that result is right first time it went down. That's after the calibration. And you can see after that it stayed like that. And you can, if you have this problem, you can look at it, immunoassay, lot number, calibrator, and everything. Like I said, it's case study, you can relate to it, you can go back actually, and you can see if you were having this problem. If you were having this problem, and a lot of times in the lab they say, oh, we had some problem for a while and then it's solved by itself. Well, maybe that calibrator finished, and then when you get the calibrator that we had, your problem will be fixed. But the thing is, if you have a third-party control, you can catch the problem early. So what we did, two controls out, company control that we thought it was going to be okay in the middle range on the average, it was even running low. So we immediately stopped the assay for free T3 until a correct calibration from outside arrives. And this is, you can see here that we disabled it. Why this example? Lower laboratories, they're afraid to stop the assay. They say, oh, you know, that's not easy, people to stop, but don't be afraid. If you get to the point where you don't think you're giving the correct result, it's better no result than wrong result. Don't be afraid to stop. Of course, you're not going to stop by yourself. You're going to discuss with the section head, and everybody's going to be involved. But at least it is an option that is until you solve your problem. Recalibrate using the newly arrived calibrator, and actually because we were told we were the only hospital that only lab that we were complaining about it, and nobody else complained. And then we found another calibrator private. Some labs in Europe had the same problem. They complained about it, and there was a new calibrator that was made, and it came. So this is cost the new calibrator. Single the company control, lot number, you can see went up after that red line on the left side. You can see it went up. On the right side, that's the Biography controls we're using. See, it went up also. So the problem was solved within the acceptable range, and we resumed patient testing. Just to summarize that one, 6-point calibrators started, 2 lot numbers of Biography outside range. Independent QC picked up the problem. The company QC was low, but within the range. CAP proficiency testing was out. And the main thing here is to note whether the company control was out or this one, as we felt that there is a problem, and we knew there was a little bit of running outside the acceptable limit low. So the main thing in this example is that stop the assay. And then a new calibrator arrived. The problem was solved with a new calibrator. The take-home message is for the medical technologists. A lot of people in the lab, you have a problem, you hear someone is telling you just establish range, or application specialist will come, he doesn't know what the problem is, he'll tell you establish range. Well, my advice, the take-home message would be never recalculate or reestablish QC range unless there is a very good justification when it's due. We all know when you establish range and what happened and how long everybody knows that. But don't go ahead and resort to that solution before you do other investigation. Companies educate client about your product. A lot of people have Unity. A lot of people have third party. A lot of people have softwares from companies and don't know how to use it. So a lot of companies should, I think, to my opinion, should push and come and visit the labs and tell people, look, we have this. Let me teach you how to use it. For laboratories, I strongly agree with this one. Use independent control, establish your own QC range, and participate in monthly QC peer comparison. And for National Guard, for our team here, I'd like to thank the staff for all the other work that they're doing. With that said, I think I'm on my last slide. I'd like to thank everybody for listening. And if there's any questions, I'm more than happy to answer them.
And thank you, Abobaker, for that great presentation. We will now start the Q&A portion of the webinar. And if you have any questions you'd like to ask, please do so now. Just click on that Ask a Question box located on the left of your screen. So let's get started. For this webinar is also a short survey available to collect some feedback, and you can submit those answers there anytime during the Q&A. So our first question is, for the GGT example you showed us, the test was performing at a higher bias for a while. Did the proficiency test pick up on this?
Yes. Yes, the proficiency test was picking up, and it was giving exactly the same picture as the third-party control was giving. Like you said on the example where it was just close to the +2 standard deviation bias, but it wasn't out. The same with the CAP reports. Every time we ran CAP, it was on the higher side, but it was in. So you know it's exactly that. What is the CAP? They're sending you samples, no concentration. They're comparing you to your peer group. Same instrument, same reagent that they're using. And the independent control is the same, where you get this known concentration, and you send the results to the company, and they're comparing you to your peer. So if everything is okay, they should perform the same. So the known samples that were given for us and the result went to CAP, it showed we are on the positive side compared to peer. And the Biography control at the end of the month was showing the same picture. It's just all the other investigation would be running, recalibrate. There was one thing, calibration factor, that was missed. So yes, if you are working good, if you're with the third-party control, CAP should have the same picture, should show you the same picture, and it did. We have a CAP of 2017. It looks exactly like the Biography report that you were seeing. and the CAP 2018 looks right in the middle. So yes, it did pick it up.
Thank you so much, Abobaker. And I want to thank our audience members for these great questions coming in. Our next question from an audience member says, can I use my calibrator material to test my performance?
Wow, this looks like a lot of people right from the lab. There's a lot of practical questions. People, if the question is, do I use my calibrator as a control? I would have to say I strongly advise against it. But since this is a case study about practical laboratory and a practical lab, if you just calibrated your instrument and you want to run a control and you don't have anything, what do? I cannot give you the answer and say no and leave it at that. If you really, really have to use, if you don't have a control, you don't have a third-party control, you don't have a company control, you don't have a pooled sample that you use as a control, all of a sudden you just woke up and you find yourself you don't have control and you have to use a calibrator as a control, please use a different lot number of calibrator as a control. Calibrate with one lot number and then use another lot number of calibrator to run the control. Because what is a calibrator? Let's say it's a 6-point calibrator, you will have a vials, A, B, C, D. And then it will give you a known concentration. The machine is going to read them, and then it's going to make a line. So actually what the machine did was it just read the concentration of those vials. And now, 2 minutes later, once it did and it drew the line for you, you're going to give it this. Let's say you decided to run vial number 2 and number 6 as a control. So you're going to run them. Don't bother running them because you just ran them like 2 minutes ago and they gave you the reading. So if you really have, the priority would be if you have a third-party control, that's fine. If not, use the company control. If not, try to use the in-house control also, like if you can save a sample that you can run it all the time. So the answer, if you are going to use a calibrator, please, as a control, please make sure you use a different lot number.
Thank you so much, Abobaker. Yes, and how often would you recommend to run the QC?
Well, it's all about practical lab people that are asking these questions. Running, how often you run the quality control, there's a lot of software that will tell you to go to WestGuard Advisory, you go to this thing, they will tell you if you are running if you're in this 1 SD rule, then you can run it twice a day. If you're 2 SD, you can run this. You can do, there's a lot of things you can go back, and people, depends on who's using and how comfortable you are and what analytes you use mainly. A lot of times we go to seminars and presentation like this and we ask those questions and people will answer. They say, oh, if you are this range, use it twice. If that is enough. And then we go back to the lab and the next day is business as usual. And then a month later you ask me and then they will say, oh yeah, we've been using it 3 times a day before and we are still using it. So just to give you an advice, just from a practical point, you run your control at 8 o'clock in the morning, and then you run it at 4 p.m., and then you run it at, let's say, 12 midnight. If the 8 o'clock control is okay, and then your 4 p.m. is bad, then you don't know if that went out at 3:59 or it went at 8:01. So you're going to look at all the samples in between. Rule of thumb is, what do you want to do? Do you want to go back 8 hours and see, like, let's say about 100 patients if you run 100? Or you want to run the control once a day, and then when there's a problem, you go back 24 hours. So it just depends on you, because you are, once it goes out, you are going to do a troubleshooting, you will go back. So how many patients and how much longer do you want to go back? Just look at it that way, and how often you have a problem. Okay?
Thank you. We have time for a couple of more questions. Here's another great question. When the manufacturer says I have to run the in-kit control, should I still run an independent control?
A simple answer is yes. Because the simple control, you're going to run it, other people are going to, you're going to be compared to everybody. Because at that kit control, if the kit was stayed outside or it was not the right temperature, you'll not know. So a lot of assays, the companies tell you, you have to run their controls to validate the calibration. run it. If the company says, yes, you can run it, but it doesn't have to add an independent control. Because by then you are comparing, you're finding out how you did compared to other people who are using the same kit and same control. So yes, actually I advise to add one more control or two.
Thank you so much, Abobaker. This has been so great. We have time for one more question. Is independent QC mandatory?
Wow. I would love to see it mandatory. You've seen now 4 cases example how we solve the problem. And that wasn't the problem of the lab that was solved as you save patient, you save wrong results. I always tell people that now a lot of people are CAB accredited. And imagine you have a lab that's doing all this work, they're running an independent control, they're doing that daily, and they're sending it outside, they're being compared to their peers 3 times a day. And there's a lab that just run either third-party control and not compared to peers, or they're just running the company control. I don't know which lab would you rather go for your blood test. This one is being compared 3 times. Now, what CAP does is CAP sends you twice a year or 3 times a year, 5 samples. 5 samples here, after 3 months, 5 samples, and at the end of the year, 5. So those are 15 samples. They take a screenshot of how you're doing, mainly. Now, how can you go wrong when with the quality control, independent control, if you're running, you'll be compared, you'll send your result. And if you run the control 3 times, so you're like having CAP 3 times a day, which is a lot better than having CAP your samples being compared to your peers 3 times a year, imagine 3 times a day. So I think in the future, it looks like it's going to be mandatory. I know that ISO 15189 says they should be considered, even if you are running the company control. And I'm sure CAB is going to catch up, and you can see a lot, the more examples like this come, the more people want to raise the bar. I think I'm the first people that I'll tell you, yes, it should be mandatory.
Abobaker Yagoot, thank you so much for your time today. And before we go, I want to thank our audience members for joining us today as well, and for their interesting questions. And questions we did not have time for today will be answered and posted in the event resources by the end of next week. And this webcast can be available for on demand in the auditorium from Friday on. If you found it informative and helpful, please share it with your colleagues. Biorad will be hosting a new QC-related webinar every month this year. And next month's topic is Cost of Quality and the Medical Laboratory 2020, and it will be held on November 18th. Please check back regularly for new topics, and remember to take a look at the booths in the exhibit hall of the virtual conference. Until next time, take care, stay healthy, and bye-bye. Thank you again, sir.
Thank you.